So in a decision rule problem, there's a couple things you need to look for first that aren't real obvious. The first one is whether or not to use a z or a t. Now in this case, they give it to you, but they won't always. And that's going to depend on whether or not you have the population standard deviation. So here it says the variance is known to be 0.66, which means the standard deviation would be zero point 0.6. It would be the square root of that. So in this case, we have sigma. We have the population standard deviation. So for our decision rule, we can use a z. And if we were going to conduct a hypothesis test, we could do a z-test. If the variance instead would come from the sample on these 200 engines, like mean pressure was 4.2 with a variance of 0.36, then we don't know the population, we'd only know the sample, and in that case, we'd have to use a T, or T procedure, or T-table. The next thing to look at is whether or not it's a one-tail or two-tail test. So in this case, it says it was believed that the valve performs above the specifications. So any directional word like above, less, more than, higher than, greater than, stronger than, these are all one-tailed hypothesis questions. So that's why we don't have an absolute value on the z. We only are looking here in the right tail. If it would have said performs below, we would have had a less than sign. If it would have said performs different than the specifications, we would have had to do both tails, so left and right. So since we just have one tail, this entire 0.02 is packed into that single tail. So if we have this distribution here, that 0.02 is going to go entirely on the right side. Now the tables that we have, well, let's see what tables they give us. So basically, on the left side then would be 0.98, right? It would be everything except that 0.02. So we need to find the z value that either gives us 0.02 to the right or 0.98 to the left, depending on which table we look at. So let's take a look there at the tables. So we definitely want to use standard normal. Again, t-table would be if we didn't know the population standard deviation. So here, this was a new add-on by Cox. I like this. This lets us actually get the right tail. The z to positive infinity will give us that right tail that we were looking for right there. So you could look up 0.02 on this chart, or you could look up 0.98 on this one. We'll give you the same answer. So let's go ahead and just do 0.02 on this one. 0.02 would be between these two. Let's get the closest one. That would be a z value of 2.05. So that means that this z value right here is going to be 2.05, and we're going to reject if the z is greater than, it's greater than 2.05. Let's take a look at a second one here. Again, first thing we're looking for is whether or not we have sigma. Do we know the population standard deviation? Believes that this... Okay, it says assume the variance is known to be this. So because we say it's known to be, that's talking about population standard deviation. And of course, we would take the square root of this. We don't need to actually calculate it, but for this particular problem, we need to know whether or not we have it. And so we do, which allows us to use z. If we didn't, if our standard deviation came from this 50-bag sample instead, then we would have to use the t procedures. So here we have, let's take a look really quickly again at what this is going to look like, and I will clear this one. Okay, so we have our distribution again, and we have 0.05. Is it a one-tail or two-tail? Well, it says underfilling. Underfilling is a directional word, and it means we can only reject the null down here. Our rejection region is only going to be one tail, and that entire 0.05 will be down there in the left tail. So now when we go to the tables, we can use standard normal. We'll go negative infinity, anything less than, anything on the left half of the distribution is going to be in the negative z section. And we go to 0.05, which would be right between these two. So negative 1.65 or negative 1.64. Shouldn't matter which one you put in. Let's put in negative 1.64, and we'll submit that.